Hello guys, so today we are solving this problem, maximum sum of distinct subarray with length k. So you are given an integer array nums and an integer k. So find the maximum subarray sum of all the subarrays of nums that meet the following condition. So basically what is happening, the length of the subarray should be k. Okay, so there could be multiple subarrays inside that array, right, in the nums. So we have to look for all the subarrays which has length equal to k, and all the elements of the subarray are distinct. There should not be any duplicate and their length should be k. So there could be multiple such subarrays. Then we have to return the sum of that subarray which makes the highest sum if we sum the all distinct number. Okay, so this is what we have to do. For example, see here, this is our nums and this is our k equal to 3. That means we have to find all the subarrays of length k that have all the distinct integers, and that makes the highest sum. So for example, if we take this one, see here, this is an subarray of length 3, but there are two duplicate, right, 3 and 3. So we will not accept this one. So then we will look to some other. So let's say we can have this thing 2 3 1, all of them are distinct, right? So what is the sum? So sum is here equal to 6, right? 2 plus 3 plus 1, which is 6. But we might have some other as well. So let's look for some other. So look at here, 3 1 5. See, this is also 3 1 5. So what is the sum here? All of them are distinct. Length is also k. So it is 4 plus 5. It is 9. So our sum would become 9 because we are looking for the maximum value. So our modified value would become 9. So our answer would be what? Our answer would be 9 because of the length k, basically the 3 length, having this subarray, all the elements are distinct and the sum is also the greatest among all the subarrays. So this is what we have to do. Now next thing is how to do that. Okay, so here the intention is we have to keep track of the duplicate numbers because we just cannot include the duplicate numbers. Then we have to go for the k size window, right? So it would be kind of a sliding window approach. Okay, so what we will have is in the sliding window we have 2-3 things, right? We have the start thing. Okay, so start point is 0. So let's say start equal to 0, and then we would have the end point. So suppose our end is basically this also 0. Okay, and initially our cur sum, let's say I have a variable called cur sum which is also equal to 0. Now what we will do is we will start from here. So end, okay, we will keep on starting with the end. So one more thing is we will keep an set as well. Okay, so because we need to have the this thing, we need to take care of the uniqueness because we need the distinct number. So when end equal to 0, so we will start from here. So what it is 3, right? So we will add this into set. So we will add this 3 and our current sum would become 3, right? And our end would become now 1. So we will come to here. So this is 2. So is 2 is there in set? No, it is not there. So we can add this 2 as well. And so what would be the current sum? Current sum would become 3 plus 2. So this would become 5. Okay. Now we will go to this guy. So this is 3. So we will check that, hey, this 3 is existing in this set. Yes, it exists. So if it is exists, we have to we have to start removing the elements from the start. Okay. So what we will do? We will remove this guy. So what is there at start? Our start is 0. So what is sitting at start? It is 3. So we have to remove this 3 from the set. So I have removed this set. So 3 is removed from the set, and also from the sum we will remove this guy 3. So 5 minus 3, it would become 3, right? So now we will check that again, is this 3 is available? No, now it is not available in the set. So we will add this 3 here. Okay, so anyway our start is now pointing to 1 because we removed this, so our start would be pointing to this location. Now we are at here, so we check that this 3 is no more in the set, so we add it here. So we will add back here as well. So 3 plus 3, what it would be becoming? So it would be becoming yeah, so this would be 5 minus 3, right? So this would be 2. So let me correct it. So this guy would be basically 2. So I will put here 2, right? Then we came here with this 3 is not there, so we added it here, and in the 2 also we are adding this. So 3 plus 2, this would become now 5. Now we'll check that what is the length. So start is 1, and our end is at here, which is 2. So 2 minus 1 plus 1, which is of length 2. So our k is 3. So we haven't found an array right now. So we will increase our end now. So our end would become now what? It would be at 3. So we will check that, hey, this 1 is there in the set or not. No, there is no 1 in the set. So we will add this. And we will add here also. So 5 plus 1, this would become 6 now. Okay. Now we will check what is the length here. So in end is 3, right? So 3 minus start is 1. So 3 minus 1 plus 1. So what is the length? Length equal to 3. So length equal to 3 and our k is also 3. So this is all equal. We found a window of size k with the distinct numbers. So we can note it down that our sum would be now 6. So we would have a capital sum, right? So we will keep the maximum value into it. So we will add this value 6 here into the capital sum from cursum. Okay, we will use just a math.max of sum and cursum. So we found 6 now. Now what we have to do is, because we found a window, now we don't know, there could be some more window as well. So we will, what we'll do, we will increase our start by 1. Okay, and so we will increase the start by 1, and whatever value was there at start, we will remove it from here. So 6 minus, it was start is here. So 6 minus 2. So this would become now 4, right? So this would be 4 now. Now we will go, our end would be increased by 1. So we will check that, hey, this 5 is there in this array in the set. No, it is not there, because anyway we removed this guy. We removed this 2, so this will remove from here as well, from the set as well. Okay. Now we will add this 5 also. Okay, we will add this 5 because it's not there in the set, and we will add into the sum. So 4 plus 5, it would become 9, right? It will become 9, and our end would be 4, right? Now we will check what is the length here. So 4 minus 2 plus 1. 4 minus 2 plus 1. So what it is? It is basically 3 only. So 3 means we have found another case. So this is equal to k only. So 3. So what is the sum here? So sum is 9 and previous sum was 6, and we need the greatest value. So we will replace this 6 with the 9. So our new value would be 9. But by that time we are at the end position, right? Our end is already at the index, this guy 5. So we would be come out of it, and our answer would be here. This 9 would be our answer. So this is the we are doing it in the single traversal, and this is a sliding window technique. We are just using a stack and that set of size k, right? We are not going beyond that k. So this is kind of a constant space only. So you can say that k is our space complexity, and our time complexity is O of n. We are doing it in the single traversal. So let me show you my corresponding code for it. So you can see here, this is my hash set I created, and these are certain variables that we would be using. Now see here, while end is less than the nums of length. Okay, so what we are doing here, I have just taken the variable into one temp variable, the whatever value at the end. Now here we are checking that if HS contains temp, means if set contains this value. See here we were checking that if set contains the value whenever we were traversing from left to right with the end pointer. Okay, so what we are doing here is, if it contains that, what I am doing, I am removing whatever there at the start index. So hs.remove nums start. And I am removing also from the cursum max equal to max minus nums start, and I am increasing this start by 1, right? Same way we were doing here. Whenever we were encountering, we were increasing this start and removing that value from this set as well as from the sum. So same thing I am doing here. I am removing from this set, and here I am removing from the current sum, and I am increasing. So after that, what will happen? If this so then we are here, max equal to max plus temp. If there is no case of duplicate, then we will come out of this loop, and here I am adding max equal to max plus temp. We were adding the values. Now here we are checking the condition that, hey, is it a window of size k? If it is a window of size k, what we are doing is, we are doing just sum equal to math.max of sum and max. Max is the current sum, but this sum is a permanent value that we are directly updating. So then see here, after doing this, what we are doing is, when we found a condition whenever we found a condition, like we found a matching condition of size 3 here, then we removed this guy from the start and we increased the start by 1. Okay, so same way we are doing here. So I am removing this from the sum, okay, and also removing this from the hash set, and then I'm increasing start plus plus because we need to check the other windows as well. So then what we will do is, then we will come out of this if this is not, if this is the matching condition, then we will do all these operation, and we would adding the hs.add for the new values, okay, that we were encountering at the end pointer. Okay, same way we were doing here. Whenever a new value is coming, we were checking in the hash set and then adding them. So that thing we are doing, and end plus plus, so we will keep on increasing from left to right. So when we will come out of this loop, from this higher while loop, we would have finally the sum. Okay, this sum would be having the greatest value. Okay, so let me try to execute my code. So I am executing it. Okay, there is some error. Let me try to submit it directly. We will check if there is any error. It would be automatically show it. Yeah, so this is 91.26% faster. So thank you for watching this video. If you guys have any concern, please make a comment over there. Thank you.